So the purpose of this activity is twofold, okay? One, and the smaller of the two, is review a little bit about osmosis and the context of reverse osmosis, which is an artificial process, okay? And the second, and more important of the two things that we're trying to get out of today is learning how to read and interpret a scientific article, okay? This is a literacy activity, a scientific literacy activity. There was a big push for this in our school division about 4 or 5 years ago. It was all about literacy, and then there was this push for numeracy. You guys at St. Francis did a lot of that. We tried, and then people got bored with it because people didn't like it. And we're like, hey, come on, it's math. We got to do this stuff, but they didn't do it. Yeah, but it's still numbers. So it's still I just want to okay. Well, it's still numbers. Good numbers. Great. So anyway, with this, what we're looking at is how to read and how to get out of a scientific article what we need. So the science department sat down and we talked to each other about what things gave us trouble when we were in university. What kind of things were difficult for us. And it always came back for us to getting what we needed out of our readings quickly. It was something none of us did well. Okay? Like I remember in university I had 5 different colored highlighters for doing my textbook reading. Okay? Because I thought highlighting's smart. I'll highlight the important stuff. Well, the first time through, basically, I highlighted everything. Everything seemed important. Okay? Well, that doesn't really save you time when you're reading through the second time because you're reading everything the second time. So the second time through, I'd use a different color. And I'd highlight about 2/3 as much as I highlighted the first time. But the 3rd, 4th, 5th time through, I'd really decided what was important. And I was highlighting in purple by then. Okay? Was that really an effective way for me to do things? No. Okay? So we started asking ourselves, because a lot of people had similar experiences, we wasted a lot of time reading and not enough time getting what we needed. We eventually got to what we needed, but it involved reading things 3, 4, 5 times, which is not effective. So how do we get things from what we read the first time? And one of the things we all realized, like in our 3rd and 4th year, when it was basically too late to save our time, was we would just be told read chapter 5, and we'd read chapter 5. We would never look at what was chapter 5 about. What was I supposed to get out of chapter 5? We would read chapter 5 and then try to figure out what we were supposed to get out of it, instead of figure out first what I should get out of chapter 5 and then read chapter 5. Would I do a much better job of figuring out what chapter? See, it's common sense to you guys. You're smarter than we were. Okay? But if I want to get something out of an article, there's a couple things I want to do. First off, I want to know first, what do I have to do with this reading? Okay? What do I have to do after I'm done this reading? What do I have to get out of it? Okay? In the case of this article, you need to answer 4 questions. So what should you do before you read the article? Read the questions. You see, that was something I never figured out. Okay? Never figured that out. Read the whole thing and then, I got to answer questions? Shoot, I got to read that all over again. Okay? Never figured it out. Okay? Read the questions first. Then what I would say would be a good idea after reading the questions would be to make note of maybe some key terms or topics that you would want to look for when going through the article. That's going to save you time. You might even highlight those things. And you can do that actually in Google Docs. You can highlight stuff if you want. Okay? So I would suggest that that's probably a good strategy for scientific literacy. So why don't we start by looking at the questions you have to answer. So the questions we want to answer here, the first one says, compare and contrast the membranes used in reverse osmosis with the cell membrane. Now it says membranes plural. So does that mean there could be more than one type of membrane used in reverse osmosis? Okay, so one of the things or 2 of the things I need to look for when I'm reading this article is, what are reverse osmosis membranes made out of? Okay, that's one of the things I need to find out. And then I'm supposed to talk about how those are similar and different from a cell membrane. What's a cell membrane made out of? Fats. Yeah, it's made out of lipids and glycoproteins and other things. It's made out of natural materials. Okay? Does it let stuff through? Yep. Small stuff or big stuff? Just small stuff, like really small stuff. Okay? Does it kind of select what can go through? Okay. And that's based on what? Okay, how does it choose what it lets in? Based on the stuff's size, And what else? Receptors, yeah, whether it's, its chemical nature, okay? Those are the two things that decide. So now that I remember those things about a regular cell membrane, now maybe when I'm reading about the reverse osmosis membranes, I figure out a little more about how they work, okay? Because something tells me they don't work very similar, okay? They would be artificial as opposed to organic. All right, second question I need to look at. What provides the force needed to move water across the membrane in both osmosis and reverse osmosis? Well, in osmosis, what moves water across the membrane? Yeah, difference in salt concentrations, right? Okay, it moves always towards the salt. Probably something different in reverse osmosis. Okay, so I need to look at how does reverse osmosis force water across the membrane. Okay. In number 3, in a short paragraph. Okay, so I've got to write like a few sentences here. Okay. Explain and justify if. That's underlined, bold-faced, and italicized. So this may be true or not true. Okay? Justify if you think reverse osmosis would be an acceptable way to conserve water. What does conserve mean? Ration, okay, or like take care of it, save it, okay, not waste it. Okay? All of those things would be things that would be implied in conserving water. Okay, so not using a whole bunch of it, which is kind of a big deal in Okotoks. Okay, you can only water your lawn 2 days a week if it hasn't been sunny and dry for 2 days. Okay, we have to be very, very careful about how much water we use. All right, so would reverse osmosis be an acceptable way to conserve water in a place like Okotoks where water conservation is important? So somewhere in this article, it's got to talk about what reverse osmosis does and whether that saves water. Okay, now, in Okotoks, we don't use reverse osmosis to treat our water. What do we use? We use good old-fashioned chemicals, okay? Because that's the way all water basically is treated in a place like Alberta, okay? Water comes into our water treatment plant. Immediately, chlorinated things are added to it. That helps precipitate out heavy metals, okay? It helps to kill bacteria and protists and things like that would make us sick, okay? It goes through a settling area where all those precipitates are allowed to settle out, filtered away from the drinking water, and then the drinking water is sent to us. Okay? You may notice that throughout the year, our drinking water's tastes change. Okay? In the spring, it tends to be a little more like chlorine than it does in the wintertime. Okay? Because in the springtime, the water levels in the river are higher, there's going to be more stuff in the water, they add a little more chlorine to treat it. Okay? Things like that. Reverse osmosis is actually a filter. Right? They force the water through a membrane. Right? We have to look at, is that going to, because really in our water treatment system, is any of the water wasted? No. Okay? It all gets treated and it all goes into the system. Okay? There really isn't any that's wasted. So we have to look at, would reverse osmosis conserve? Would it do a better job of that? Okay? Would it clean the water and save water? Okay. For number 4, it was mentioned in the article that reverse osmosis was used to ensure impurities were removed from certain products like wine and syrup. Okay, so we already know that reverse osmosis is a way to clean water, but now it's saying it can also be used to clean other things. Okay? Can you think of any reason why purists might disagree with the use of this process in the making of these products? Okay. If we're looking at syrup, like especially maple syrup, comes right from the tree. Okay? If we don't filter that, does it taste different than if we do filter it? Okay? Because the filtering is going to take stuff out, right? Okay? Purists might say that's part of the taste, or that's part of how this works. So there's got to be something in the article there about that process. Okay? So explain why you think they might disagree. Okay? All right. So those are the 4 things we got to look for. Now, as we go through, there may be words that we don't understand, that we're not familiar with. I've highlighted a few, okay, that sometimes give people trouble, but maybe you have some that give you trouble as well. So I'm going to give you a little bit of time to read the article, and then I'm going to go through some of the terminology. When we first started doing this literacy stuff, Guy did a very, let's say, meaningful demonstration to us. Okay? He said, how many of you as teachers would be happy if every kid in your class got 95%? I'm like, well, we're not stupid. That seems pretty good. I'm going to put my hand up for that. He said, okay, let me demonstrate just how bad that is when you're talking about literacy, about people being able to read. And he took out a big, thick paperback book. And he said, if I understand 95% of this, here's how much of the book I don't get. And he tore a section of the book off about that thick, 5% of the book. And it ended up being like 50 pages. I was like, so now, do you understand what happens in this book? Do you get the story? If you don't understand 50 pages, we're kind of like, no, I suppose not. If you miss one key term in here, and it has to do with the rest of the article, does the rest of the article make sense? Not as much. Okay, so if there's a term you don't understand, write it down or highlight it, and ask about it in a few minutes after I've given everybody a chance to read the article. Okay? All right, I'll give you some time to read the article. Okay, any terms that you guys would like clarified? I have a few that I'm going to go over, but if you have any that you would like clarified, I'll go over them now.
Skeletal fluorosis.
Skeletal fluorosis. Okay, skeletal fluorosis is a disorder where the bones get soft, weak, can lead to like bow-leggedness. And it happens because fluorine ions will bond with calcium ions from the bones and pull them out of the bones, making the bones softer. It can also cause like browning of the teeth. Okay, so other terms here, guys. Any other ones from you guys? Okay, so desalinization simply means the process of essentially cleaning salt water and making it useful for drinking. Right? That's not something we do here because obviously all the water out here is fresh. But if you were in an area where there was no source of fresh water, no wells or rivers, then you would be forced to desalinate ocean water. That is an expensive process and very water demanding process. Okay, unprecedented means like we've never seen anything like this before. Okay, there's no precedent set for this. Okay, things like that. Torrential flooding is like what we had in 2013. Okay, when the rivers all flooded around here, that was torrential. It just wiped out everything. Okay, semi-permeable membrane. Okay, that's what we talked about actually earlier, and before we even started reading the article. Semi-permeable means some things can get through, some things can't. Okay, when we're looking at osmotic pressure. Okay, we talked about that earlier today as well. That's the pressure that's created by having differential salt concentrations on either side of the membrane. Okay, concentrate just means how much of a salt is dissolved in water. Okay. Bars of pressure. Bars are a unit of pressure. Okay, it's an imperial unit. We actually use pascals. Okay, in the metric system, pascals are a unit for pressure. There's bars and there's millimeters of mercury, and there's all kinds of different ways to measure atmospheric pressure. Okay. Voila is French. There you go, or there you are. And then we talked about skeletal fluorosis. Impediments. Okay, so the word impediment means to essentially stop the flow of something. Okay, so if you have like a speech impediment, for example, okay, that means that there's something that is stopping your speech from being clear and flowing. Okay, so if you stutter or something like that, it's an impediment to your communication. It impedes your communication. Right? If you were to have your car stall in the middle of the deerfoot, you would be impeding traffic. You would be reducing its flow and its effectiveness. Okay, so that's what an impediment means. Okay, WHO and UNICEF. WHO is the World Health Organization. Okay, they're the people that are kind of from the UN that are responsible for containing outbreaks and epidemics and studying disease and things like that. Okay, when we had that whole SARS scare, they were the ones that ineptly tried to stop air traffic and keep people from moving it around the world. And we realized just how badly we do that and how it's almost impossible to stop, okay, the movement of a sickness in today's modern world because of air travel and things like that. They found out that basically there's absolutely nothing we can do short of grounding every airplane on Earth, okay, in order to stop that. And even then, it probably wouldn't work. Right? UNICEF is the United Nations International Children's Emergency Fund. Okay, so it's a United Nations effort that sends money and resources to places where children might be impoverished or in danger due to natural disaster, political strife, and things like that.
Is it 50 to 60 bars of pressure, like a lot of pressure?
That's a fair amount of pressure, yeah. Not enough to obviously tear the membrane, but enough that you're forcing water through.
Okay.
It's not going to go through on its own. Okay, any other ones there? All right, so pretty good several sentence answers, okay, for each of the 4 questions. When you're done, you can just submit it, okay, and then you can get to work on your plant transport lab after that, okay. But make sure you do a good job of this. It's out of 15 marks, okay. Carefully answer those things, especially number 3. Number 3 is the question people mess up most, right? That has to do with the if and the conserve part of that question. Make sure you're looking at how reverse osmosis works in terms of how much clean water is produced versus how much wastewater is produced. Okay? Things like that to look at.